Hey everyone, my name is Renaud Tarnek and I'm a Firebase GDE based in Brussels, Belgium. Today, we are going to take a look at how we can easily export Firestore data to BigQuery, then execute query using aggregate functions, and finally use Data Studio to build reports based on this data.
Before starting the demo, let's first set the context in 4 slides. Most of the business applications need some reporting and analytics capabilities on the data stored in their database. While Firestore as a NoSQL database has a lot of advantages, when it's time to do some aggregate calculations, it can rapidly become cumbersome because you need to maintain counters for all the dimensions you want to aggregate and for all values in those dimensions. A much more flexible and efficient solution is to use the Export Collections to BigQuery extension to export Firestore data to BigQuery, the serverless, highly scalable enterprise data warehouse offered by Google Cloud. And then use a reporting tool like Google Data Studio to visualize and analyze the data. With the Export Collections to BigQuery extension, you can send real-time incremental updates from any Firestore collection to BigQuery. The extension will listen for document change in your specified Firestore collection, then exports the changes into BigQuery. In other words, the data in BigQuery is a mirror of your content in Firestore. For our demo, we are going to use the data model of a furniture store, which sells sofas, tables, chairs, etc. We have 3 Firestore collections: products, customers, and orders. As you can see, since Firestore is a NoSQL database, we do not hesitate to denormalize the data by, for example, duplicating the customer data. Okay, it's now time to start the demo. We are in the Firebase console, in the Cloud Firestore part. As you can see, the database is empty at the moment. Before populating it with our demo data, let's first configure the Export Collections to BigQuery extension. We click on the Extensions menu item at the bottom of the vertical menu. The page shows a subset of the available extensions, among which we can see the Export Collections to BigQuery one. Note that you can open the full list by clicking on the Explore All Extensions button. But let's click on the Install button in the card corresponding to the extension we want to install. The extension configuration is divided in 4 steps. But actually, the 3 first steps are mainly informative ones. The first step indicates that the BigQuery API is enabled and that a specific cloud function is created. The second step is about billing, and the third one is about the new service account that is automatically created. Okay, let's look at the fourth step in detail. We first configure the locations of the cloud function and of the BigQuery dataset. Here we override the default values and we choose the Europe West 1 region. Then we configure the Firestore collection. We choose the Customers collection. Since we want the BigQuery table to have the same name, we copy this value and paste it in the table ID field. Now let's configure the BigQuery dataset. We name it as Firestore_sales. Finally, we keep the default value for the last item, which is about table partitioning. Okay, everything looks okay, so we click on the Install Extension button. The extension will install over the next few minutes. But remember, we need to install 2 new instances of the same extension, one for the products collection and one for the orders collection. The configuration of these 2 additional instances is actually exactly similar to the configuration we've just done. Only the table name is going to change. So with a bit of video editing magic, let's move forward and get to the state when the 3 extension instances are configured. Okay, now that the 3 extension instances are installed, we can upload our demo data to Firestore. But before doing that, let's have a brief look at the BigQuery console. We are now in the Google Cloud console and the BigQuery module or console is displayed. By default, our Firebase project, which is also a Google Cloud project, is pinned, but it does not contain any dataset. Let's go back to the Firebase console, open the Firestore part, and upload some demo data. To do so, we are going to run a small Node.js script which uses the admin SDK. The upload is done. Let's refresh the Firebase console to display the 3 collections. We can see that they were populated with test data. For each collection, we have uploaded several hundreds of documents, and consequently, the 3 extension instances have been triggered and have copied the Firestore data to BigQuery. Let's look at the BigQuery console. Again, we need to refresh the page to see the new data. We expand the project node, and now we see the dataset node. If we expand it, we see for each Firestore collection a table and a view. The table stores a full change history of the documents within the collection, and the view represents the current state of the data within the collection. You can find more details about these 2 BigQuery resources in the extension documentation. Let's now query the view which mirrors the product's Firestore collection. We click on the view name. The view schema is displayed in the right pane. By clicking on the query button, we open the query editor. Let's use the SQL language to query the entire view with select star from. This should bring up all the data contained in the products collection. Each row corresponds to 1 document in the Firestore collection. All the columns corresponding to the schema are displayed. In particular, we can see the document IDs, the last operation on the documents. Here we only have create operations since the documents were just created. And on the right, we see Firestore document data in JSON format. Okay, great. We can actually query in BigQuery all the data mirrored from Firestore. Well, this is not really different from natively querying the Firestore database, and doesn't add a lot of value, to be honest. So let's now look at something that is much more interesting. We are going to build a view that does some aggregation on our Firestore data, which is something we cannot do in Firestore as a NoSQL database. As you can see in the query editor, the query calculates the number of products by category. For that, we use the count aggregate function. We also use a JSON extraction function, JSON_value, to retrieve and transform the JSON data. You'll find the link to the BigQuery JSON function documentation in the video description below. So let's run the query. We get only 5 lines, 1 line by product category, which displays the total number of products in the category. That's some data that is very interesting for the teams in the sales or marketing department, for example. Again, this is something quite cumbersome to do in Firestore, as explained in the slides at the beginning of the talk. How can you share this data with your colleagues? One option is to directly export the query results from the BigQuery console. You can save them as a CSV file or to a Google Sheet. But there is a much more user-friendly approach to build a report based on this data in Google Data Studio. Data Studio is a free tool that can turn your data into informative, easy to read, easy to share, dashboard and reports. The first step is to save this query as a view that we name products by category. We then switch to Data Studio by simply opening datastudio.google.com in a browser. We click on the blank report button and we select BigQuery as our data source. We choose the Google Cloud project, the Firestore_sales dataset, and the view we have just created. A new untitled report is created with a default table based on the view data. Let's replace the last column showing the record counts by another metric, the product quantity. Then we rename the two column headers. We add a summary row that shows the total quantity, and we sort the first column in ascending. We switch to the style panel, and we remove the first column showing row numbers, and we also remove the pagination controls. That's it for the table. Let's now add a title and rename the report. Finally, we add a pie chart. By default, it takes the data from the table and displays it in percentage. Great, our report is complete. Let's click on the View button in the upper right corner to visualize it. We see that we can easily share this report with other people. For example, we can invite people to the report. We can also schedule an email delivery. And this option is very interesting. For example, we can automatically deliver every week an up-to-date report to our colleagues from the sales department. We can also get a link to the report or download it as PDF and send it by email. Okay, so now we have a nice and user-friendly report containing aggregated data from our Firestore database and that we can easily share with end users. But let's look at what happens when new data is created in Firestore. We switch to the Firestore console and we create a new product document with a new category, wardrobes. The doc is created. Let's switch back to Data Studio and to our report. We click on the refresh option and the report is updated with a new category that we can see at the bottom of the table. That's it for our first report. We are now going to rapidly look at two other reports. First, let's imagine that we've just received a request from the sales department. They are interested by a report on the sales by product category. We first need to build a view that aggregates our sales data by value and by quantity. Let's switch to the BigQuery console. We click on the Compose New Query button and we paste the code for the new query. Note that this time we use the sum aggregate function. We also need to use the cast conversion function in order to convert the values of total price and quantity to respectively a decimal and an integer. Let's run the query. We get 5 rows, one for each product category with some cells. And the table also shows the total sales and quantity for each category. Okay, we save the query as a view and it's time to use it in a new report. But we are not going to look in detail at how to create the Data Studio report. We have already done that for the previous report. Better, we will directly switch to the finalized report and look at what we can get from such a view. So here is the report based on the sales by product category view. At the top, we have a table showing the total quantity and total sales, by value, but also as percentage of the total. Below, we have two pie charts showing the same information in a graphical visualization. Let's go ahead and look at the last report. This time it's going to be different compared to the first two reports. Instead of reporting on aggregated data, we are going to take advantage of the drill down capabilities of Data Studio. We switch to the BigQuery console and again we write a new query. You can see that this query is not aggregating data. In order to drill down to a low level of detail, the view needs to return the 778 orders document that we have in the Firestore database. Okay, like before, we save the query as a view. Then we switch back to Data Studio and look at the corresponding report. So here is the all orders report. As you can see, it is quite simple because actually we want to focus on how we can drill down into the report data. By default, the table shows the total sales in terms of value and quantity, but we can drill down from the overall total to a yearly total and then to a monthly total. Look at the overall totals and in particular at the total quantity. 1,039 items were sold. If we hover on the arrow in the top of the table, we see that we can drill down from product categories to years. We then see the same total quantity figure, but now the table displays the total by years. Let's choose the year 2020, during which 396 items were sold. And let's click again on the arrow to drill down from year to months. We now see that the 2020 overall sales quantity and value are broken down by month. Okay, let's reset the table and choose a specific product, chairs. We can do on this specific product category the exact same drill down that we've just done, by year, and then for a specific year, by month. Finally, note that if the data changes in Firestore, by simply refreshing the report, we will get the latest data, exactly like we did with the first report. Okay, that's the end of the demo. Let's recap what we just learned. Firstly, we saw how to configure the export collections to BigQuery extension to easily mirror our Firestore data in BigQuery. We then went over a simple aggregation query in BigQuery, and we detailed how to create a Data Studio report to get a nice visualization of this aggregated data, and how to share this report with end users. Finally, we looked at two other reports based on our Firestore data, and in particular, at a report allowing us to drill down into our sales data from a higher level of detail to a lower one.
Hopefully this talk provides a good idea about the many possibilities offered by BigQuery and Data Studio in terms of Firestore data aggregation, analysis, visualization, and reporting. I hope you all have a great Firebase Summit.